Now we are going to another thing about, we stop the video. Another point in the chapter 11, we have calculus with parametric. What do you mean by calculus? So you have Cal 1, Cal 2, advanced calculus. So what do you mean by calculus? Okay. What do you mean by calculus? For example, when I have a book, I want to, there's no cover, just write calculus. So in my mind is what? Yes. Integrals and derivatives, exactly. So the subject is what? Means that in this book, we have a function. We have a limit, we have integrals and derivatives. When we say calculus, the calculus means that, okay? So generally, even in some books, they say calculus, integration calculus. Means that this book is the part of the calculus. So mostly, or the subject will be around the integration and derivatives. That's why we have a calculus of parametric equations. Means that now we are going to deal with what? Finding the derivative of parametric equations. You know what's a parametric equation? We have a t. Now, before we say anything, we know the derivative is what? Can be represented by like that, right? You know, y prime dy over dx. Okay. But now I know the function of y. We see y equal to t plus 1. X is equal to what? Square root of t, for example, right? Now I know the function of t, y is by t. I know x now is another function by t squared. Am I right? So now I have two functions. They are depend on the parametric t. So that's why when I say d derivative y by what? I say derivative y by dt, as well derivative of x by what? By dt. You got it, dear? That's why we put that one, because we know each of the x and y, they change from the simple function. Now, let me review it for you. When you see f of x equal to, for example, x squared, or you can say y with the x parameter, x variable. Then when I want to find derivative, I say dy or df does not make a change, dy by dx, right? And you will get some result. Understood? But now, no. Now I have y equal to t squared. So I can represent in my mind x is the function by t. And also y is equal, for example, square root of t plus 1. I say also y is a function by t. That's why when I want to find just only the derivative of x, I say dx over dt. Am I right? When I want to find derivative of y, I say dy by dt, because just y is contain what? T only. But when I want a whole derivative, I know is equal to dy over dx. But also y has a package with t, and x has a package with t again. You got it, dear? Understood? Good. And sometimes it's better to replace it and get the result by the dx by dy. Look at here. This is the second derivative. To find it directly, second derivative, we know it was y double prime. Look, you find the previous one. Now the result of here means that the result of here, this is the y prime. So put that result again, drive it by t over dx by t again. And actually that will make you confusing, to not like it. But when you apply the example, you will understand what I mean. So now I have x second and t is a value, and we have what? We need to tangent curve. Later we are going to find the tangent curve. Let me say that here, we need a first derivative. Okay? Now, my duty is what? To find that derivative. Derivative is what? I know dy prime, and I know dy by dx, and I know dy by dt, again dx by dt. How? Derive dy by dt, you'll get what? Yalla. Derivative of tan is equal to what? Second square of t. Thank you, second square of t. How about derivative of second? Second tan. Am I right? You got the idea, right? So this is dy by dt. So you can see second square second tan, and the result will be what? You know, second over tan. Do you have any problem? Any question? Okay. Now, tell me about, I'm going back to the example. The question is what? Find the dy y prime? No. He say what? Find tangent. In physics, when I say find velocity, in mathematics, when I say find slope, again, when I say find tangent, my idea, our problem or our equation is what? It should be derivative, right? When I say tangent, tangent is what? Tangent is derivative. When I say slope, slope is what? And derivative. When I say velocity in physics, it's what? Derivative, first derivative, I mean. When I say acceleration, is what? Double derivative, right? Now you know what I mean. So when I say tangent, find the tangent curve at that point means that find the first derivative at that point. But what's changed in there? We have a parametric equation. So our equation is what? Our equation is finding the derivative here at that point. So I have a first derivative is equal to second tan. Then I'm going to review, substitute the value, and I will get the result. And how about tangent line? Before we say tangent line, the equation of tangent line is what? Thank you. Y minus y naught. Yeah. Exactly. What's m? The name of m. Slope. Thank you. What's the equivalent name of slope? First derivative, right? What's that? Tangent line equation. Equation of the tangent, or we say tangent line. So you can see we have what? They give us the 2 points. So this is x naught and y naught. Also we have t is pi over 4. So means that find slope at t equal to pi over 4. So now solving the example again, I have what? Second t and y equal to tan of t, and I have t at what? Pi over 4. Also I have a point. It was, am I right? Good. So he say find what? Find tangent. And I know for finding tangent, I wanna find these all together. I have that one, but I don't have a slope. So I say m at pi over 4 equal to first derivative at pi over 4. Am I right? And I know first derivative is dy dx, and I know is equal to what? Dy dt dx dt. And it will, I don't know, it was the result. It was, let me write the just result. You know how to do it. Pi over 2. Sorry. The result was what? Square root of 2. Am I right? Okay. And later I will give you the clue how to find the second of pi over 4, pi over 6. Don't worry. In that 11.3, I'm going to fill this gap for you without calculator. Okay? So I'm skip that one to there. Understood? Good. So don't worry about how to get the pi over 4, how to get the sine and cosine. So we are going to control them. Then during the exam, you know how to find them. Okay. So m, it was like this. So now x minus y naught and square root of 2x minus x naught. Unfortunately, it was minus what? 1 square root of 2x minus square root of 2, and you will get the result here. Understood? This is the equation of tangent or tangent line. Okay. Now I have another example, finding the second derivative. Okay, finding the second derivative. So how we find the second derivative? We know. We see that in the previous one. We say second derivative is what? Is equal to dy prime over dt dx over dt. This is the rule. I told you it's not easy to get it by the example. My example is what? Y equal to what? X is equal to that. Y equal to that. X minus x squared. Sorry, t minus t squared. And how about y? T minus t cube. Am I right? Good. So first of all, look at here. I'm going to find the red one, the red box. So the red box is equal to what? We need y prime first, right? To d it. So y prime is equal to what? And we say that one many times, I think. Am I right? Yalla, tell me, is equal to what? Y1. 1 minus, okay. 3t squared, 1 minus 2t. Am I right? Good. So d that one to get the green box to understand together. So we need to find the d of that one to numerator. Am I right? Yes, I'll let you find d of that one, that box, over t. So it's equal to what? So I say d y prime over dt is equal to what? Is equal to d over tt, that box. Am I right, Jamaat? Okay. So equal to what? Thank you. Jaraduja. Denominator square. Okay. Denominator. Derivative of numerator minus numerator derivative of denominator. Am I right? And the result, as you know, I'm lazy for that. And the result will be what? Here we are. 2 minus 60 plus 60 square, and of course denominator. Okay, this is the dy prime over dt. Okay, it remains what? To put that one, that result, over what? We get double y. To put that result over, and don't try to find it again. Even if you want to find it again, it's okay, but you have it in the previous one, right? We have it here. So again, it's over what? That result. I see that result. 2 minus 16 plus 60 squared over 1 minus 2t, all of them squared, over 1 minus 2t again. And it will be what? 2t cube, and that's all. You know, reciprocal about 2, you'll get what? The result will be 2 minus 60 plus 2t squared, 1 minus 2t cube. That's all you got. So you know how to find that one, and you know what's meaning that one over that one, right? Understand? Good. Later, I'm going to deal with the example number 3 and some length. Yes, we have a length. And also, I think we have area revolution. Yes, area by revolution. We are going to deal with that situations.